And welcome to Cambridge Chemistry channel. Be sure to like the video and subscribe. It really helps the channel to grow. Today I will discuss the qualitative analysis of organic compounds. This is the experiment question number 3 of paper 3. You are provided with 4 aqueous solution Fa4, Fa5 and Fa6 and Fa7. Each solution contains one of the following: alcohol, aldehyde, carboxylic acid and ketone. And I think you are very well aware of test of these compounds. You are to perform the test below and from the results establish which type of organic compound is contained in each of Fa4, Fa5, Fa6 and Fa7. After each test, discard the contents of the tube into the 250 centimeter cube beaker labeled organic waste. This is the precautionary measures because organic compounds are flammable and can catch fire if reached near the naked flame. Rinse and reuse the tubes for the remaining test. Record your results in the table where no reaction has taken place. Write no change in the appropriate box in the table. Test A. Place 1 cm depth of each of the solutions Fa4, Fa5, Fa6 and Fa7 into the separate test tubes. To each tube, add small quantity of magnesium powder or turnings. Identify any gas given off and record the tests you used to make the identification. You know that magnesium is a metal, and this is the test for this is the chemical properties of carboxylic acid. When you add magnesium to the acid, effervescence of gas can be seen. So it might be this test for carboxylic acid. This test for carboxylic acid, because no change with the alcohol, no change with ketone, no change with the aldehydes. So place 1 cm depth of each solution Fa4, Fa5, Fa6 and Fa7 into the separate test tube. To each tube, add small quantity of powdered sodium. This is again to identify the carboxylic acid, because metallic acid properties, metal, sodium metal carbonate and metal hydroxide. So if effervescence can be seen, so definitely that test tube contain carboxylic acid. Place 1 cm depth of each of the solution Fa4, Fa5, Fa6 and Fa7 into separate test tubes. To each tube, and 1 cm depth of 2,4-dinitrophenyl hydrazine. You know, this is the identification test of carbonyl group, and if red precipitates can be are appeared in the test tube, so that test tube contain carbonyl group. Place 1 cm. This is test for carbonyl functional group. Place 1 cm depth of each of the solution Fa4, Fa5, Fa6 and Fa7 into separate test tubes. Place 2 cm depth of aqueous silver nitrate in a boiling tube and add to 1 cm depth of aqueous sodium hydroxide. This will produce a precipitate of silver oxide, and you know that you are very well aware of this test. This is the Toller reagent test, which is going to identify aldehyde and ketone. If positive observations uh, are recorded, then it is definitely aldehyde. If no change, then there is ketone present in the solution. Use a dropping pipette of add dilute aqueous ammonia to this mixture until the precipitate of silver oxide just dissolves. Do not add an excess ammonia. To each of the tubes containing Fa4, Fa5, Fa6 and Fa7, add 1 cm depth of the silver containing solution you have just prepared. Place 1 cm depth of each solutions Fa4, Fa5, Fa6 and Fa7 into separate boiling tubes. To each tube, add a few drops of acidified potassium manganate. And if you remember that when we add acidified potassium manganate in alcohol, it is going to colorless. The color is because acidified potassium manganate is purple in color. When you add acidified potassium manganate in alcohol, so alcohol decolorize acidified potassium manganate, so it is definitely for alcohol. Now this is the observation which I have recorded for you, that test A we have no change for in case of Fa4, Fa5 colorless gas produced, which gives uh, pop sound with lighted supplant. So this is hydrogen gas, or it is with magnesium when you add magnesium powder in carboxylic acid. No change, Fa6 no change, it means Fa5 might be carboxylic acid. Next test, no change with Fa4, a colorless gas produced which gave white precipitate with lime water. So this is again confirmation of carboxylic acid. So test C, जो है, look at test C, place 1 cm depth of each solution. So this is carbonyl, so definitely there is no change with the Fa5 confirmed carboxylic acid. Yellow precipitate in case of Fa4. Test C, 1 cm depth solution into separate. To each test tube add 1 cm depth of 2,4-dinitrophenyl hydrazine. So it means yellow precipitate over here. So this compound containing carbonyl, Fa4, Fa6, and no change with Fa7. Now no change of test D. Test D is the silver mirror test, tolerant reagent test. So Fa4, in case of Fa4 no change, in case of Fa5 no change, and black precipitate of silver mirror test. It means that Fa6 contain aldehyde, because this is the tolerant reagent test. So Fa6 contain aldehyde, and Fa7 has, so it means Fa7 has no aldehyde. No change of test E. Test E, acidified potassium manganate. This is test for alcohol. So it means Fa4 has no alcohol, Fa5 has no alcohol. Purple color decolorize or disappears, so it means Fa6 contain alcohol, and again Fa6 contain Fa7 contain alcohol. Purple color of aqueous potassium manganate disappears, because if aldehyde is present or alcohol is present, but Fa6 has aldehyde test as well as alcohol, it means alcohol is also oxidized to form aldehyde. So that's why positive test with the Fa7. Purple color of KMNO disappears, so it has no aldehyde, means this is aldehyde and this is alcohol, because there is no change with the tolerant reagent. So that's why Fa7 has alcohol. So identify the type of organic compounds present in each of the solution, Fa4, Fa5, Fa6. So from our observation, we identify that Fa4 contain ketone. C test, yellow precipitate, so with the 2,4-dinitrophenyl hydrazine. So this is ketone. Fa5 carboxylic acid, we observe hydrogen gas with magnesium ribbon when we add magnesium ribbon in carboxylic acid or Fa5. So effervescence is found, which extinguished lighted supplant with pops. A colorless gas is seen when we add sodium carbonate, so carbon dioxide gas is evolved, which turns lime water milky. So it means Fa5 confirm is going to confirm Fa5 is carboxylic acid, confirmed by observation in test B. Aldehyde, Fa6 is aldehyde because there are two confirmatory tests with the D test, that aldehyde because this is a positive test of aldehyde, that when with Tolan reagent, when aldehyde with Tolan reagent, black precipitate or silver mirror test, silver mirror, yeah, black precipitate of silver oxide is formed, and this is it confirmed that aldehyde is present. Again, when we add potassium manganate, because aldehyde is oxidized to carboxylic acid, it to carboxylic acid, so again confirm that this is the aldehyde. This is the positive test of the aldehyde silver mirror test. Now Fa6 contain no change with all tests, so uh, with test E it decolorized potassium manganate, so it is alcohol. So in this way we are going to uh, identify the different functional groups of organic compounds. And you know that you are very well aware of these tests. You should know all these tests, that which is going to which uh, compounds, right? Hopefully you understand this. Thank you.